Now we're going to look at quadratic functions and models. We have two different forms of a quadratic function. The first one is the general form. It's in, should be a recognizable form back when we were factoring trinomials, but I've got f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. If you'll notice, it says a can't equal 0, for if it did, this term wouldn't be here, and then I wouldn't have a quadratic anymore. I'd have a linear. So I have to have an x squared somewhere in the problem in order to have a quadratic. Now I've got a standard form of a quadratic function. I've got f of x equals a times the quantity x minus h squared plus k, where a, h, and k are real numbers. Again, a cannot equal 0. Now when it's in this form, I could FOIL out the information inside the parentheses, distribute the a, and then collect like terms. If I do that, then I'm right back to the general form. We're going to look mostly at the general form because about 95%, if not more, of your problems are in that form. So I'm just going to focus on it. So again, to get standard form back to general, FOIL out the parentheses, distribute the a, collect like terms, and you're back to general form. Now, first thing we're going to look at is how to graph a quadratic function. So when an equation is given in general form, your first job, well, first step, there's two parts here. Your first step is to find the x value of the vertex by this formula. Now, the b and the a come from the a is the coefficient with my x squared, and the b is the coefficient with my x. So if I put negative b over 2a, I'll find the x value of the vertex. Now, it's sort of infrequent in math to be able to find two things when you do one process. Not only do I find the x value of the vertex, but I also find the axis of symmetry. And hopefully, if I remember, I'll talk about that again here in just a bit. So minus b over 2a, got to know that. Now, once we find that value, then I'm going to find the y value by putting the x value back into the original equation. Okay? Second thing, or step, make a chart of values starting with a vertex and get two more x values to the left and right of the x value of the vertex. Then find the corresponding y values by using your calculator. Now, the next thing, what we're going to do is we're going to find the concavity. The concavity is how the parabola looks. Okay? If my a value, remember that's the coefficient with my x squared, is greater than 0, meaning it's positive, it's concaved up, just like that. Or if my a value is negative, my parabola is concave down. Okay, so all my parabolas will look like that if my a value is negative. Fourth thing is we're going to graph the vertex and the other points you found, and then we connect them. And you should be able to see the symmetry, referring to the axis of symmetry, with respect to that. Okay, got an example. I've got f of x is equal to negative x squared plus 2x plus 4. So indicate what your a, b, and c values are. And I've got the formula, which you've got to know. So if I substitute these values in, let me move this over just a little bit. So there's my b, 2 times a, so that would be a negative 2 over negative 2, so that should give me 1. So that's my x value of my vertex, and also x equals 1. Remember, that will be a vertical line. That's my axis of symmetry. Now let's substitute 1 back up here, f of 1, that will give me my y value when x is 1. So let's see what I've done. Oh, it's way too slow. Let me use my little thingy mouse. Okay, so I put 1 in for x. Please use parentheses when you substitute. And if you use your order of operations, we should come up with 5. Now let me get my calculator. Remember storing? Remember, I like to store. I'll move my calculator in a little bit. So 1, storing for x. I've got negative x squared plus 2x plus 4. And that should also give me 5. So now that's my vertex right there. Oh, let me put it back down. So important information. Vertex is 1, 5. Line of symmetry is x equals 1. Please use this equation. If someone asks you what's the line of symmetry and you say 1, I will count it wrong. So this is an equation, so you've got to have that. And if you just keep x equals and you do all that, you have it. X equals 1. That's your line of symmetry. So now, let me see. Step 2, because I've done step 1. Step 2, I'm going to make a chart of values. So let me move this over. Don't want you to see those. So here's my vertex, my x value, my vertex, and I went to the left. So to the left of 1, I've got 0, negative 1, and I went to the right, I have 2 and 3. And if I substitute those in, one at a time, I will get these y values. Okay? But let me show you a quicker way. Let me get my calculator back up. Let me do y equals. Now, I already had it typed in here, but I want you to see something. Remember that second enter, and that will paste. Or, you know, when I did it, I haven't done it here, I don't think. Nope. But when you do second enter, whatever the last thing you have in your view screen, second quit. Remember that was the last thing I did? So if, So if I go here, I can do second enter and it will paste it in. Saves you time. But I got here to show you a quick way to find these values. If you do second graph to access the table, there they are. Here's my negative 1, my 0, my 1, 2, and 3, and here are my y values. Very quick. Oh, let me go down just one. Well, I have to go down all the way down here because I want to get x equals 4. Look at this. Here's your vertex. If you go to your left one and right one, notice your y values are the same. Left or right 2, your y values are the same. Left or right 3, your y values are the same. That's the symmetry that's involved. So let me put this down. So let me see. I need to, where am I? Oh, I'm not here yet. Sorry, I'm getting excited here. Step 3, I need to indicate concavity. My A value is negative 1, so it should be concave down. Okay. 4th, graph the vertex and other points you found. What did I do here? Oh, graph the points. So I went ahead and did that. You need to go ahead and do it on yours. See if you can graph the points and also put in your axis of symmetry, because I'm going to delete that, and there they are. I wonder if I can connect. Let me connect. See if I can. So I go up. I hit my vertex, and now I'm coming down. Cool. I've not tried that on here before. So I did step 5. So let me go ahead and get rid of that because I connected my points. Notice your, this is my line of symmetry or axis of symmetry. If you'll notice, what's on the right is on the left. Okay? And that's all there is to it. So you need to do some problems, practice this. Talk to you later. Bye-bye.